Hey everyone, Brian Beeler and Kevin O'Brien coming to you from the Storage View Lab. And we recently went out to San Jose to spend some time with Vast Data. That was pretty cool to get out of the shop and go see people, humans again.
Travel's always fun these days.
It is fun. And part of their big launch was around a new data storage node called Series that leverages all sorts of new technologies, including Bluefield, including E1.L long rulers and storage class memory. So their data nodes now in 1U are extremely dense.
Yeah, I'm not sure we've seen anything denser. Like it's packed full of QLC and
SCM.
yeah, there's tons of stuff inside of it that you wouldn't really expect in a 1U chassis.
But as fundamental and as cool as we think this storage is, Vast Data is very much a software company leveraging storage and servers in creative ways to produce great results for their customers. And as a big piece of that software is a GUI, which is another thing that we don't always see in high-end storage systems like this.
Yeah, especially, I mean, you're looking at CLI interfaces for a lot of the competition, and it's always fun when you can click things versus having to type in stuff into like a bash or a putty session.
Well, especially for me, because I'm quite visual and also not technical when it comes to CLI, so I will just break it all. But to break it all down and to give us a walk through the Vast Data software GUI and maybe reset it for us a little bit in terms of architecture, we've got storage nerd Howard Marks joining us today. Howard, how are you?
I'm fine, Brian, but I've always preferred geek to nerd.
Well, this is my video, so you'll have to live with my choices today.
Yes, sir.
Welcome. And you guys came off that launch pretty hot, a lot of excitement. We did the pod with Jeff and talked for well over an hour about architecture. So I'm hoping that you can distill that conversation into less than an hour so that we can get into the GUI.
Oh, I can distill it down into a couple of minutes, but it's important that we go over it because one of the things I want to show you in the GUI is how you trace data flows. In a large distributed system, one of the problems that people typically have is a user is having a performance problem and they're not sure which nodes that user's hitting and where the bottleneck is. And this feature in the GUI is really helpful for that. But if you're going to trace a user's request, you have to know what all the places they're going to go are called.
Okay. Let's take a look at that.
So if you look at the slide, at the top, we have the users, the client systems that are accessing the vast universal storage system via NFS, SMB, and/or S3. And then those users connect to virtual IP addresses that are associated to the next layer down, the stateless protocol servers that run in containers that do all of the work in the vast system. And that's where the secret sauce is. Those stateless containers do everything from interpreting the NFS to managing the metadata that's down at the bottom in the HA enclosures that can be our original 56 SSD enclosure in 2U or the new series enclosure that holds 338 terabytes in 1U in QLC and then includes additional storage class memory to act as the write buffer and to hold all the system metadata. So this lets us scale the compute part of the cluster independently from the capacity part of the cluster, dedicate compute nodes to applications for QoS. And because all the work happens in the front end containers, but all the state and data is stored in the enclosures, we can scale the system asymmetrically. So today, customers who have our existing 2U enclosures can add series to those clusters. They can add the generation after that. It's all transparent. It's all one storage pool. There's nothing for them to manage about that asymmetric cluster, and that's really unusual at scale.
Well, Howard, that's true for the compute nodes too, right? So you're on a platform now, but as new platforms come out, new CPUs, new technologies there, you can take advantage of that as well, right?
Yeah, the system just load balances and dedicates tasks to the CPU that's least busy. And so if they have different levels of ability, it's kind of like communism, from each according to their ability to the cluster according to how many threads they have free.
Well, and that's, I mean, you say that in sort of as a minor differentiator, but traditionally when we think about storage platforms, we see this all the time where the slowest node holds up everybody else, right? And so this is fundamentally different.
And therefore they make you build clusters of heterogeneous nodes. And when the new model comes out, you have to do a forklift upgrade. And
Which is
our system allocates
painful.
Yeah.
according to what each node's ability is so that we can run these heterogeneous clusters and support the system for 10 years instead of the 3 to 5. And then we really would like you to buy new hardware and rebuy your software. So we're going to make support expensive model.
Okay, well, let's get into your software because that's one of the key differentiators, and I want to make sure that we, take a look at that and show everyone what we're talking about when we talk about things like Vast Data has a GUI. So what do we have to look at there?
Sure. Well, here you go. Here's the opening dashboard. It is a modern HTML5 GUI. But the most important part is not that the GUI does everything, but that the GUI consumes the REST API. So everything that you can do in the GUI, you can do through the REST API. That's all documented in Swagger. And if you use your browser's show code feature, you can do things the first time in the GUI and have the browser show you the REST syntax that was used, so you can cut and paste and replicate into your scripts. So what there isn't is paging through the 5,000 page reference manual, trying to remember what the command to change the IP address on some management device is.
That's pretty useful.
The opening dashboard shows you the things that you're likely to be interested in. How full is the system? How busy is it? And various counters to that effect. And then the health of all of the devices. So C nodes are those front-end servers. D nodes are the NVMe routers within the enclosure. So there's two of them because they're HA. And then there's the SCM SSDs and the QLC SSDs. The interesting part comes when we start looking at things like analytics, where we can very quickly see who are the users who are generating the most traffic, where are they accessing that traffic, where are they accessing that data from.
And is this the first entry view into that route tracing you were talking about before?
Well, that's a more common feature, top actors. That
okay.
tracing feature here is data flows. And so I can select this user, Howard F. Flow, and highlight that that user is running his tasks on the host 172.205.93, and that host is accessing the system through this virtual IP address, and therefore through this C node, and the little thermometers underneath even show how busy those various items are. And so I can hover over that node and see how many users, how many hosts, how busy it is, and quickly determine where the bottleneck is. And if I determine that this C node 3-2 is the bottleneck, then I can clear that isolation and say, show me everybody and all the flows that are hitting that, in case I want to reload balance. So this is the kind of thing that in conventional parallel file systems takes days of log analysis. And not only can we do this in real time, but I can say, show what it was like 10 minutes ago when the user actually issued that ticket. I can say, so Ray is the guy who was complaining. Let me see. Well, let's clear everything. And then select Ray, and say, what was the path Ray's requests were taking? Where's that bottleneck appear to be?
Interesting. And so with your dynamic load balancing, for lack of a better term, what's the clarity in this report? You talked about it being real time, but as
well, it's every 10 seconds.
Okay. So then if a node goes, offline for maintenance or something, right, then you can see those workloads shift into the other other workflows.
Right. And since we do non-disruptive upgrades, nodes can go offline because we're performing an upgrade, and the virtual IP addresses that node was serving will get assigned to other nodes. And that may have created 15 minutes ago a 2-minute situation where normally each of those front-end servers has one virtual IP address in the pool. We've rebalanced because one's offline, and now one of the other ones has two. And so it has more load until that device comes back up. And if we saw something like that, we would tell the customer, instead of having 4 front-end processors and 4 virtual IP addresses, have 4 front-end processors and 12 virtual IP addresses, so that when things get reallocated, they're allocated in smaller slices. But even so, that front-end processor that got 2 IP addresses and is serving more user traffic will be relieved of all of its work doing migration of the data from SCM to QLC and garbage collection and all of the back-end maintenance that the system does because it's busy serving the users.
Okay, excellent. That makes a lot of sense. And that visualization for whatever admin has to answer these questions has got to be pretty useful.
I especially like the retrospective part, because I can look at it at the timestamp that's on the ticket and see what the guy was complaining about then.
Mm-hmm.
And my favorite calls when I was on the help desk were the ones where we can go, yeah, we did have that problem. Sorry, it's fixed now.
Even better.
Are you able to see movement in terms of, say, something hit at a weird point in time, but it maybe over a minute period, something happened 20 seconds in? Are you able to kind of scale across that?
Well, you can slide the time range, or select what timestamp you want to look at.
Okay.
If we're for the kind of complex problems, I would go to the basic analytics. Now that I know that the problem is on CNode 3, I would set CNode bandwidth alerts so that I could get a trigger and the timestamp of when it exceeded some threshold.
Okay.
And then I would take that to feed what timestamp I wanted to look here. The other uncommon function is capacity estimation. That normally if you want to see a chart like this that shows how big all of the folders in your file system are and lets you dive in and check how big the subfolders are and reports the data reduction. Okay, that data didn't reduce very much. Let's go pick something.
Now, are these generated in real time? How are these? How accurate are these?
These are sampled, so they're estimates, but they are in real time.
Okay.
So this is being generated by metadata queries against the metadata base in real time. And so here we can see that this data reduced 4.4 to 1, and it's data we generated by backing somebody up with Commvault. And no, I don't know what the Commvault settings were.
Well, point being is that you guys do offer data reduction, which is, depending on the use case, maybe less effective for encrypted media files, maybe more effective for other things, right?
Encrypted data is challenging, although we have had one customer who was using us to store encrypted backup data, and they encrypted so much data with the same encryption key that the deduplication started working.
That's kind of
I
scary.
wouldn't count on that, but we were starting to get 20% data reduction and wondering where it came from, and I had to go look into it. But we do see substantial data reduction for things like from backup applications, because while Commvault or Veeam or whoever the backup vendor is does data deduplication, it's generally limited in some way because a Commvault or a Veritas can't tell the customer, you need 768 gigabytes of memory to hold the hash table so we can dedupe on small blocks. So you need a $40,000 server to run our software. And so they dedupe on big blocks so they don't need as much memory. Where we have all of that data in the SCM and it scales with the system. So we have one fine-grained reduction realm for many petabytes.
Well, that's a good visualization. Are you guys still seeing the average data reduction in that 3 to 4 range? Is that still common in your field?
So we have, in addition to this local set of analytics, some 85% of our customer systems report back to our centralized analytics platform. And the last time I looked, that was a little over 3-to-1 data reduction across the entire fleet of installed systems. And so there's some systems in places with encrypted data or pre-compressed media files that see less than that. And that, of course, means that there are other customers that see substantially better.
Sure. Okay. So what else stands out to you in the GUI that's worth noting?
Um, Protection policies, in that when you define a protection policy, we combine there you go. We combine the snapshots and replicated snapshots into one policy so that you can have so this system doesn't have, unfortunately, a replication partner defined. But if I had replication set up between this cluster and another, here where it says take a snapshot every 1 hour and retain a local copy for 4 hours, there'd be another column where it would say and retain a replicated copy for 16 hours. And so I can manage both the local and replicated copies from a single policy. And if you select our indestructible snapshot option, you say, this policy should make snapshots that can't be deleted even by an administrator before their expiration date. The policy itself is also locked, and you need to get the exception time-limited token from support to make changes, because we don't want to protect only against ransomware. We also want to protect against rogue administrators.
Or whoopsies, administrators.
Yes, excuse me, rogue or clumsy.
Be careful.
Clumsy.
Okay.
I'll stick to
Good.
clumsy.
Good. It happens.
Yes, we've all made mistakes. And in my consulting days, I used to say that I'd never want to hire a storage administrator who hasn't made a big enough mistake that he thinks he's not just lost his job, but put his employer out of business. Because once you have felt that fear, you're much more careful.
There you go. You learn, get burned once and not again.
Yeah. Now, the guy who's done it 3 times, you don't want to hire him either.
Right. That could just be incompetence.
You want the guy who did it once and never again.
So what else, as we think about what you guys are doing at Vast Data, is maybe different here or in terms of administration than a typical storage cluster would be?
Well, the biggest thing is what's not here.
Okay.
There's no defining volumes or file systems or any of those intermediate abstractions. When you get a vast cluster, you arrive at the dashboard and you have one storage pool. And then you can go to the element store and you can create a view. And a view is a protocol independent name for what S3 calls excuse me, for what S3 calls a bucket, excuse me, a bucket, and what NFS calls an export, and what SMB calls a share. Since we allow multi-protocol access to any of those via any of those protocols, we needed a protocol independent name. And so I can define view policies that say that shares that are marked SMB only are only accessible via SMB, and they're only available to users via Active Directory, and that all of the SMB name restrictions are enforced. So it's case knowledgeable but insensitive, the way SMB is. And then I can create a view and therefore create the folder that holds that view, and users can access the system. And it's really as simple as that. I don't need to decide what the protection level is. We only have one protection level. It's higher than everybody else's protection level. A vast system can suffer 4 drive failures simultaneously before losing data. And because all of the front-end processors work in parallel to rebuild whenever there's an SSD failure, the simultaneous is a very small window before we rebuild the first failure. So you don't have to decide, I need this protection level for this data and that protection level for that data. You get the highest protection level, and you get 2.7% overhead for that protection level. So you're not picking, well, I want less because 2.7 is too much to pay. 2.7 is a very low degree of overhead. High protection, low overhead. Why do you need choice? You don't have to create multiple volumes. You don't have to create meta objects to create independent file systems. It's one namespace. You create views. Users connect to those views via their selected protocol, and they access their data. It's
That's
simple.
really easy.
Yeah.
The
So
main thing you don't need to do is install clients that have to match the kernel version of all of your servers. It's NFS. It's standard protocol. It just works.
So you talked about failures. I presume then somewhere in here you've got a view of the systems in this cluster and some SSD.
Yeah, so I can look at clusters, and then I can, within the cluster, look at the hardware. So a C box is the 4-server enclosure, a 4-server appliance that holds 4 of the front-end servers. C nodes are those individual front-end servers. Don't get scared by the red. All it's saying is that the management service is only running on this C node. Not saying there's something wrong. I know administrators jump when they see red, but I can look at the individual SSDs and check their status. I can look at the NICs and make sure that they're all up and connected. And I can dig down as deep as I want.
Now for fun, do you have one of the data nodes you can pull up as well and take a look at the goodies inside there?
Yeah. And then this is our first generation enclosure. Unfortunately, I don't have a series system running that I can access remotely. And so here's the left view and all of the SSDs that load from the left, and the back view of the 2D nodes and all of the network cards. And so if I was getting errors from an SSD, I could start its LED flashing so that the tech in the field knows exactly which one to pull out.
And the purples are your SCM, I imagine?
Purples are the SCM, the blue are the QLC SSDs.
Okay.
And series, everything loads from the front or the back, so we don't need the side views.
Right. Yes, we dismantled a series node and have a whole write-up on that. So we, in addition to the software, so we'll link to that in the description of this video, so you can check that out if you want more detail on any of this. So back to the dashboard here then, and overall, yeah, I mean, Kevin, your thoughts on this compared to other things you looked at in the past?
And so some enterprise platforms don't necessarily always provide the performance with the historical data, well, especially in real time, at a main screen. Some require outside analytics software to tie into to provide the information. So it's nice having it all kind of at your fingertips. And especially without having being HTML5, I mean, you could load this up on a tablet attached to the same network and get a quick glance of how things are operating. And then if something maybe bad was happening, drill in further from a PC. But it makes it just really easy to manage.
And if you do like Grafana or something for keeping track of your whole estate, you can feed that through the REST GUI. We have many customers doing that. It should be the REST API.
So that's great. We appreciate you taking us through that, Howard. So for anyone that wants to learn more, I referenced the piece that we did. Where can we send them, or give us a link for Vast Data as well to explore more, or maybe ask for a demo?
So, hello@vastdata.com is the email address.
Okay.
Vastdata.com on the web. I am particularly proud of vastdata.com/white paper, where I explain how the whole system works.
Okay, so depending on your level of interest in terms of the tech or the sales or just learning more, there's a bunch of different options there. This was great, Howard. Thanks for jumping in and walking us through the software.
Always a pleasure.